another electrostatic question. Alright, we're going to start with 7.2, where they need us to draw a labeled free body diagram showing all the forces, important forces, acting on sphere R. Let's read the question. Two identical small metal coated spheres, R and S, are given identical charges of 40 nanocoulomb. Alright, let's just highlight each. They are suspended at the same point from a ceiling by means of an identical light, inextensible insulating threads of equal length. The threads are negligible of mass. When the system is in equilibrium, there you go, the angle between the threads are 60 degrees, while the distance between R and S is 5 centimeters. Now, first of all, they need us to draw a free body diagram. So let's go and do that. So we have FE. In other words, the force between R and S will be our electrostatic force. There you go. We have the tension, which is at 60 degrees there. And we have gravity. There you go. Now, using this, we can go and draw a vector diagram. Right, we have gravity going down. We have Fe going to the right. And we have our tension to an angle. And therefore, we know that this one is 60 and this one 30. And our 90 degrees. Alright, now that wants us to calculate the mass of R. Now, as you can see, we will be able to do that using the sine law and our little triangle here. But first of all, we need this Fe mass. And we're going to calculate the force between the two charges using our normal K, Q1, Q2 over R squared. Let's go and do that. Q1, Q2 over R squared, which is 9 times 10 to the power of 9, 40 times 10 to the power of negative 9, converting it to coulomb, and that is for both of them. So therefore I'm going to square it over 5 times 10 to the power of negative 2, converting it to meters. And that will give us Fe being 5.76 times 10 to the negative 3 newtons. They will be repulsive because they are exactly the same. Now let's go and take this and go and place it into a little triangle. So Fe being 5.76 times 10 to the power of negative 3. Right, we know that Fg is mass times gravity, which is 9.8. Now let's go and say that Fg over sine 60 is equal to Fe over sine 30. There you go. Let's go and do that. So Fg, which consists of m times 9.8 over sine 60, is equal to Fe, which we've just calculated, over sine 30. Here you go, cross multiplication, divide by 9.8, and your mass will be 1.018 times 10 to the power of negative 3 kgs.